The Internet of Things or IoT is a system interrelated computing devices, mechanical and digital machines, objects, animals or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human to human or human to computer interaction. A thing in the Internet of Things can be a person with a heart monitor implant, a farm animal with a biochip transponder, an automobile that has built-in sensors to alert the driver when tire pressure is low, or any other natural or man-made object that can be assigned an Internet protocol or IP address and is able to transfer data. How IoT works? An IoT ecosystem consists of web-enabled smart devices that use embedded systems such as processors, sensors, communication hardware to collect, send and act on data they acquire from their environments. IoT devices share the sensor data they collect by connecting to an IoT gateway or other edge device where data is either sent to the cloud to be analyzed or analyzed locally. Why IoT is important? The Internet of Things enable the people of the world to live and work smarter, in complete control over their lives. Not only to offer smart devices for home automation, IoT is essential to the business. IoT provides businesses with real-time analysis into how their systems are performing, delivering insights into everything from the performance of machines to supply chain and logistics operations. Thus, IoT is making businesses less vulnerable to higher overhead costs, but reducing the same and empowering them with abilities to be more competitive. In a continuous process, IoT is getting enriched with standards and frameworks. There are several emerging IoT standards like IPv6, ZigBee, LightOS, which is a Unix-like operating system for wireless sensor networks. Then again, OneM2M, which is a machine-to-machine service layer that can be embedded in software and hardware to connect devices. Next, data distribution service. Then Advanced Message Queuing Protocol AMQP. Then COAP, Constrained Application Protocol. And of course, Long Range Wide Area Network. IoT frameworks include, like you know, Amazon Web Services AWS for IoT. ARM Embed IoT is a platform to develop apps for IoT based on ARM microcontrollers. Next is Microsoft's Azure IoT suite. You definitely have heard of Google's Prilo Beef. And of course, Calvin is an open source IoT platform released by Ericsson. Consumer and enterprise IoT applications are really becoming very popular. The real-world applications of the Internet of Things are increasing in supersonic. It's ranging from consumer IoT and enterprise IoT to manufacturing and industrial IoT, which is IIoT. IoT applications span numerous industries, including healthcare, automotive, IT, telecom, and energy. In the consumer segment, home automation is a big example. Smart homes that are equipped with smart thermostats, smart appliances, and connected heating, lighting, and electronic devices can be controlled remotely via computers and smartphones. We have noticed the immense use of wearable devices today. Wearable devices with sensors and software can collect and analyze user data, sending messages to other technologies about the users with the aim of making users' lives easier and more comfortable. Wearing devices are also used for public safety. Let's move on to healthcare. Robotics are not new in healthcare. In healthcare, IoT offers many benefits, including the ability to monitor patients more closely using an analysis of the data that's generated. IoT systems are also implemented in inventory management for both pharmaceuticals and medical instruments. Let's not forget agriculture. IoT-based smart farming systems can help monitor, for instance, light, temperature, humidity, and soil moisture of crop fields using connected sensors. IoT is also instrumental in automating irrigation systems. In a smart city, IoT sensors and deployments such as smart street lights and smart meters can help alleviate traffic, conserve energy, monitor and address environmental concerns, and improve sanitation. Right from 1999, when Kevin Ashton in his presentation mentioned about Internet of Things, to the present day, IoT has evolved from the convergence of wireless technologies, micro-electromechanical systems, microservices, and the Internet. The convergence led to the revolution and has helped to break down the silos between operational technology and the information technology, enabling unstructured machine-generated data to be analyzed for insights to drive improvements and thus leading to a organized and structured flow. The future of IoT has the potential to go beyond our imagination. Advances to the industrial internet will be accelerated through increased network agility, integrated artificial intelligence, and the capacity to deploy and automate. What we have been watching in sci-fi movies are now gradually being transformed into reality. Guys, self-driven car is one such example which IoT combined with AI made possible. So let's make it simple, guys. An IoT system consists of collection of data through sensors, microcontrollers, and antenna integrated in various IoT devices, proceeding to transferring those data through IoT gateway or hub, to end with analyzing those data by various user interfaces like smartphone or other devices, analytics for business operations like CRM or ERP, and further analytic tools in the backend systems. So we need to think about things differently as IoT is evolving from Internet of Things to Internet of Everything.